Okay, question number 1 on the topic 3 review. It says, without graphing, classify the system as independent, dependent, or inconsistent. All we've got to do is to find two things without graphing. You got to be able to find the slope, and you got to be able to find the y-intercept. Let's do that real quick for the two equations. The first equation is x minus 5 is equal to negative y. So in order to get this in slope-intercept form, all I've got to do is get y by itself, and it needs to be a positive y. So right there it has a negative 1 in front of it. So to get that to become positive, you just divide everything by negative 1. A negative divided by a negative becomes a positive 1y. And then if I divide everything over here by a negative 1, it's a positive 1 divided by a negative 1, which would give you a negative 1x. And then a negative 5 divided by a negative 1 would be a positive what? Positive 5. So what's the slope of this equation? The slope of this equation is negative 1, and the y-intercept's a positive 5. Now let's do the same thing for the second equation. We've got to be able to figure out the slope and the y-intercept of the second equation, and that second equation is this. 2y minus 10 is equal to a negative 2x. So all I've got to do is get y by itself. If I can get y by itself, I'm pretty much done. So I move my 10 across, so that negative 10 is going to become a positive 10. So this is 2y is equal to a negative 2x plus 10. And then now to get the y by itself, just divide by 2. 2 divided by 2 is 1. 1 times y is y. So this negative 2 divided by positive 2 would give you a negative x, negative 1x. Okay, and then 10 divided by 2 is a positive 5. So what's the slope of this one? Negative 1. What's the y-intercept of this one? 5. So what if you have two equations that have the same slopes and the same y-intercepts? It means that the two equations are exactly the same. They're right on top of each other. If they're right on top of each other, how many solutions do they have? Infinitely many. So that means they're what type of a system? It's not independent. Independent means one solution. Okay? Inconsistent means no solutions. So the only thing it can be is a dependent system. You depend upon many. Remember that? So it has many solutions, so that's B. Alright, so let's go to the next question. Without graphing, classify the system as independent, dependent, or inconsistent. Once again, I just got to figure out the y-intercept and the slopes of each. So my first equation is 2x is equal to y minus 7. And then my second equation over here is 4x minus 2y plus 4 is equal to 0. Just put them both in slope-intercept form so I can find the slope and the y-intercept. So the first equation, you just move the 7 over. If I take that negative 7 and move it to the other side, it leaves y by itself. It's y is equal to what? 2x, and then what happens to that negative 7 when I jump it across? Becomes a positive 7. Very good. So what's the slope of this one? The number in front of the x is the slope. And then what's the y-intercept? Remember the y-intercept is indicated with the letter B. It's 7. Do the same thing for this equation. To get the y by itself, I just need to move that 2y across. Why the 2y across? Because I've already got my x, and I've already got a y-intercept kind of over here on the left side. So just move the 2 to the other side, and that would leave me with 4x plus 4 is equal to a positive 2y. Now, to get the y by itself, I just divide by 2. Divide by 2. So y, because 2 divided by 2 is 1, 1 times x is x, so y would be equal to 4 divided by 2 is 2. And then this positive 4 divided by 2 is a positive 2. So what's the slope here? 2. What's the y-intercept here? 2. So what does that mean? It means that if I were to graph this one, it has a y-intercept of 7. Let's just say that's a 7 there, and a slope of 2. So you rise up 2, run 1, right? It looks something like that. Well, this line here has the exact same slope, but a different y-intercept. So it crosses here like a positive 2 with the exact same slope. If it has the exact same slope, are these lines ever going to cross and have a solution? No, they're parallel lines, which means I have no solution. Which one of these means no solution? C, inconsistent. Very good. All right, let's go to problem 3. Which of the following is a method used to solve a system of equations? Okay? So what all methods do we have for solving systems of equations? We have substitution, we have elimination, we have graphing, we have matrices, right? Row reduced echelon form. Okay? And that row reduced echelon form was a fancy name called what? Gaussian elimination. Right? I said, hey, we don't have to do it pencil and paper. That's when we RREF it. The same thing is called Gaussian elimination. So I can solve a substitution, graphing, Gaussian elimination, and elimination, which is not there. So all of those are possible ways of solving systems of equations. And next chapter, we'll do matrices. So matrices are used to solve systems of equations as well. All right, so let's go to problem 4. Solve this system by substitution or elimination. Okay, so if we're going to solve that by substitution or elimination, how do I do that? All right, I'm going to show you the pencil and paper way of solving this. Okay, even though I showed you row reduced echelon form and all that other stuff, we're going to solve it, okay, with pencil and paper. So if I use substitution, all I've got to do is to solve one of these equations for a particular variable. Well, the first equation is solved for y, right? And the second equation is solved for y. So to solve it by substitution, all I have to do is to take this y value, which is 2x plus 8, and substitute it in for y wherever I see y in the second equation. See, that's a y? We'll replace that y with a 2x plus 8. So this y really is 2x plus 8 is equal to 3x minus 1, and then now solve that equation like you did in Algebra 1. And then we know what x is. So to solve that, you just subtract 8, subtract 8. So I've got 2x is equal to 3x. What's a negative 1 minus 8? Negative 9, right? And then now I've got to get my x's on the same side. So it doesn't matter where you put them. I'm just going to take this 3x here and I'm going to move it to the other side of the equation. So when I jump it across, it becomes a negative 3x. And that's a positive 2x is equal to a negative 9. And they combine like terms. What's a negative 3x plus 2x? Negative 1x, right? Is equal to a negative 9. Now to get x by itself, just divide by negative 1. Negative 1 divided by negative 1 is 1. 1 times x is x. When what you do to one side, you got to do to the other. So a negative 9 divided by negative 1 would be a positive 9. So x is equal to 9. So I know x is 9. What would y be equal to? Well, to figure out what y is, either plug that x value into the first equation or the second equation. Just pick one. I'm going to pick the first one. To get y, it's equal to 2 times whatever x is plus 8. And if x is 9, just plug in a 9 for that x. So 2 times 9 is 18 plus 8. So what's 18 plus 8? 16, 26. So my x is 9, my y is 26. Now you could have solved that by row reduced echelon form and all that other stuff, but you'd have to put it in standard form. So I figured substitution would be just as easy. Okay? Alright, so that answer choice should be C. Everybody get C? Alright, let's go to 5 then. Solve the system by substitution or elimination. Okay, so here's my first equation. It's 2x minus y is equal to 2. The next one is 2x minus 2y is equal to 4. If I'm solving this with pencil and paper, okay, which is the only way I'm going to show you on this review, okay, I'm going to use elimination. Here's why. It's in standard form. See how my x's and my y's are lined up? And my constants are lined up? So all I have got to do is either add these two together or subtract these two together if my leading terms, okay, or any of these are the same variable to the same coefficient, with the same coefficient. So if you notice this x and this x obviously are lined up and they have the same coefficients, then all I have got to do is add them together and they would eliminate, right or wrong? Not add them, but I need to subtract them. So subtract these. And then it would eliminate it because it's a 2x minus a 2x, which is 0 x's. And then a negative y minus a negative 2. Well, wait a minute. How do you subtract? What's your rule for subtraction? You have to add the opposite. So really this is plus a negative and then this negative would become a positive. So it's really a negative 1 plus a positive 2, which is a positive 1y. And then 2 plus, you got to add the opposite there, would also be 2 plus a negative 4, which is a negative 2. So y should be equal to 1y. 0x's plus 1y is just y, would be equal to a negative 2. Now that I know what y is equal to, how do I find x? Now you just substitute that y into the other equation wherever you see an x. So pick the top one, I guess. The top equation originally was 2x minus y is equal to 2. So if y is a negative 2, just plug in a negative 2 wherever you see a y. So this would be 2x minus whatever y is equal to 2, and y is a negative 2. So now I just solved that. So my first step would be to subtract, which is the same thing as add the opposite. So that's really 2x plus 2 is equal to 2. Get my variables on one side, constants on the other, so subtract 2 to get rid of that positive 2. So I get 2x is equal to 0, and then I divide by 2. So x is 0. So what's my solution to this? 0, negative 2. Now I know I've showed you faster ways, but this is just the way I'm doing it here. So if you did that on your calculator by row reduced echelon form, that's fine too. But it didn't ask me to do it, so I'm doing it one of those two ways. Okay? Alright, question number 6. Solve the system by substitution or elimination. Look, see how my y's are the same? It's the same coefficient aligned with the same variable, so would I subtract these or add them to eliminate my y's? You should subtract them, shouldn't you? So if I subtract these two, remember your rule is to add the opposite. So I need to subtract. So really, I'm going to add the opposite, and the opposite. And then the y's would be eliminated because a positive y plus a negative y is 0. See, but then I have to take this negative 1x plus a negative 2x, which is a negative what? 3x. And the y plus a negative y is 0. A 2 plus a 1 is what? 3. So negative 3 times what is 3? To solve that, divide by negative 3. Divide by negative 3. So x is negative 1. So now that I know what x is, how do I figure out what y is? Pick an equation and just substitute it in. So I'm going to just substitute that x value of negative 1 wherever I see an x in the first equation. So to figure out what y is, I'm going to take the negative of whatever x is, because that's what that first equation says. Negative x plus y is equal to 2. And x is a negative 1, so it's a negative of a negative 1. And a negative of a negative 1 is positive 1 plus what is 2. So 1 plus what is 2? Can y'all do that mentally? 1. And 1 plus 1, 2. So my solution would be x is negative 1, y is positive 1. So that should be A. Everybody get A for 6, hopefully. Let's go to 7. Graph the solution of this system. Look. See how the first inequality says y is greater than a 1x minus 5? Should be a dashed line. Where's my boundary line? Well, my boundary line is the same thing as the equation of y is equal to 1x minus 5. So this means it has a y-intercept of negative 5. So this graph is going to cross at a negative 5 like it does in A. And it would be a dashed line with the slope of 1. The number in front of the x is 1. So this looks good. So you're going to rise up 1, run 1. Rise up 1, run 1. And then y is greater than that, so I'd be shading all the values above that boundary line. So far A looks good, doesn't it? So let's graph the second one, which is 3x plus y is less than or equal to negative 2. I can't graph it until I get the y by itself. So this is 3x plus y is less than or equal to a negative 2. So to get the x by, or the y by itself, I'd have to move that entire 3x across the inequality, which would make it a negative 3x once it jumps across. So this would be y is less than or equal to a negative 3x minus 2. So the boundary line is a solid boundary line, just like that one is. So that's good so far. And it has a y-intercept of what? Negative 2. This y-intercept is at a negative 2, yes. Does it have a slope of negative 3? Well, to figure it out, if it has a slope of negative 3, that's my rise over my run. So from that y-intercept, if I rise down 1, 2, 3 units and then run to the right 1, am I on that boundary line? Yes. And where would I be shading? Down below that boundary line. So the double shaded region would be shading above this one and below this one. Where they would overlap is that in that section right there. It looks like it is to me too. So yes. Okay? Everybody good with that? What's wrong with B? It has the dash one where it should be solid. Okay, so everything else should be wrong other than that one. So it should be A. Alright, let's go to the next problem. Graph the solution to that system. So to graph the solution of this system, I have y is less than or equal to x plus 2. So if I were to graph that, it crosses my y-intercept at a positive 2. Right, and my slope is a 1. Because the number in front of the x is a 1, so I'd rise up 1, run 1, rise up 1, run 1. And it would be a solid line, and I'd be shading in all the values that are what? Below that. And then if I graph my second one is y is greater than the absolute value of x minus 3 plus 1. So how do you graph the absolute value of x minus 3 plus 1? Well, this is a vertex of the V-shaped curve, so it's some kind of shift of the parent function, and that minus 3 shifts the parent function to the right 3 or left 3. If it's minus 3, remember it's always minus the positive h value of that, so it's minus a positive 3, so it's shifting it right 3. So the vertex is not here, it's right here. And then it's a V that's pointing up, right? Would it be a solid line or would it be a dashed line here? This should be dashed. Why is it a dashed line? It's greater than. So it really should not be that way. It should be a dotted line or a dashed line here, like that. And then I'm shading in all the values above it. So where would they overlap? Right in that section right there. So which one shows the dash V? Well, it's B. Right? C has a dash V as well, right? But what else is the issue with that? Not only is this shifted right 3, but it's also shifted up 1. So it's actually wrong. It should be here. And then it should be a dash V. My fault. So it should look right in here, should be that double shaded region. So I didn't move it up. So this is wrong. It's a right graph, but it's just not a dashed line, right? So is this right 1, 2, 3, up 1? Yes, with the dashed line shaded above it. Is this the right graph of this boundary line of x plus 2? It's a y-intercept of 2 and a slope of 1. So rise up 1, run 1. There we go. And then shade down below it. So it should be B. Trey, did you get B? Put B. Let's go to the next one then. You understand why? Any questions on that one? We good? All right, let's go to 9 then. Question number 9. You have 10 fewer quarters than dimes and 5 fewer nickels than quarters. The total value of the coins is 475. How many quarters, nickels, and dimes do you have? Okay, so we've got 3 different equations, right? Because we have to find 3 different values. We have quarters, nickels, and dimes. So the first sentence says you have 10 fewer quarters than dimes. So what do I know about the number of dimes? They're more. So the number of dimes, which is D, would be equal to, well, it says it's 10 fewer quarters than dimes. Okay? And 5 fewer nickels than quarters. That's wrong. So it says if you have 10 fewer quarters than dimes, that means you have more dimes, right? So my dimes would be equal to what? My quarters plus 10. Got it? Or I could write it another way. The quarters is equal to the dimes minus 10. Either way. And it says I have 5 fewer nickels than quarters. So if I have 5 fewer nickels than quarters, my quarters would be more there, and it's equal to 5 more than the nickels. Bless you. And it says the total value of the coins is $4.75. So if I take the dimes plus the nickels plus the quarters, let's just say the nickels, the value of the nickel is 5 cents per each of those, plus the value of the dime is 10 cents per each of those, and that's D. So if I have 2 of those, it's worth 20 cents. And then the value of the quarters is 0.25 times Q, and that's equal to what? What's the value of all of them if I add it all together? $4.75. Okay, how many quarters, nickels, and dimes do I have? Well, how do I solve that system of equations? Well, I could do it by substitution. I could do it by elimination. There's a lot of different ways of solving that. Let's do this one by row reduced echelon form. Can we put it in standard form and do it that way? This one already is. The nickels, the dimes, and the quarters are all lined up. What about this one? How would I do that in my calculator? Okay, all I got to do is get my nickels on the same side as my quarters. So I move the nickels over, so I've got 1/4, so that would be what? Q minus my nickels, so my nickel would be a negative N, plus 0 dimes would be equal to what over here to this 5? Okay, so that's like a -1 and that's like a +1. Everybody good with that so far? All right, the other equation would be this one. So put my quarter over there with my dimes, so that would be a -Q plus 1D. -Q, then I've got a 1D, and then 0 of these nickels would be equal to 10. Now, can you rewrite that as a matrix? The matrix would be what? 0.05, 0.1, 0.25, and then you have your augmented matrix, which represents that equal to, would be 475. This one would be -1, 0, 1, and then 5. The next row would be 0, 1D, -1, and then 10, and then just RREF it, and let's see what we get. So how do I enter this as a matrix in my calculator? I can just go to menu. Once I go to the calculator section, go to menu. I can go to matrix, which is 7. Create a matrix. What size matrix is 1? And I want 3 rows by how many columns? 4. And then I need to RREF it, so I forgot to put that in there. So you can just type it, RREF, and then put that matrix in parentheses, and then now put in each element. 0.05 tab, 0.1 tab, 0.25 tab, and then a 4.75. Tab over to the next row, which is a -1, a 0, a 1, and then a 5. A 0, let me go back. A 0 tab, 1 tab, -1 tab, and then what? 10. And then I should just be able to hit enter, and it tells me I've got 5 what? What's my first row representing? Remember, these are nickels, dimes, and quarters. So my nickels are 5. My dimes would be 20. And my quarters would be what? 10. So 5 nickels. Which one says 5 nickels? This one. 20 dimes. And 10 quarters would be C. You got it? 5 nickels, 20 dimes, because my first one is my nickels is 5, my dimes is 20, my quarters is 10. So that'd be C. All right. Let's go to the next problem. You'll probably have one like that on the test where you have to put it in row reduced echelon form. All right, here's the next question. You burn 4 calories per minute walking and 10 calories per minute running. You walk 10 to 20 minutes each day and run 30 to 45 minutes each day. You never spend more than an hour running and walking together. How much time should you spend on each activity to maximize the number of calories you burn? Will you have exercised enough to burn off a 500 calorie meal? Okay. So what we want to do in this problem is kind of list the facts. First of all, it says you burn 4 calories per minute walking. So the calories that I can burn is 4 per each minute, and we'll just say that's what W represents. W equals the minutes walking. And then let's just let R be equal to the minutes running. Alright, so if I burn 4 calories per minute walking and 10 calories per minute running, if I combine those two activities, okay, will I burn so many calories? Well, how many calories does it look like that I want to burn? Okay, So the question says, how much time should you spend on each activity to maximize the number of calories you burn? Okay, so I want to figure out what's the maximum number of calories that I can burn from that. So I really want to maximize my calories. So this is kind of my objective function, right? Is how many calories can I burn to maximize that total combined exercising period? Right, and then there's some restrictions here. It says you walk, the time that you spend walking, which is W, is in between 10 to 20 minutes each day. So that's in between 10, which means greater than or equal to 10, but less than or equal to what? 20. That's a restriction on the problem. And the time that you spend running is in between what time? 30 and 45 minutes each day. You follow that? Then the next sentence says you never spend more than an hour running and walking together. So if I take my running time plus my walking time and add it together, it's never more than an hour, which is less than or equal to 60 minutes. Y'all good with that? So those are constraints on the problem. So it said, how much time should you spend on each activity to maximize the number of calories you want to burn, to maximize this function, in other words. And then answer the next question, will you have exercise enough to burn 500 calories? So let's graph our constraints. Well, first of all, the time that I spend walking, let's just call that the x-axis, and the time that I spent running, we'll call that the y-axis, has to be positive, right? Because I can't spend negative time, so it's somewhere in quadrant 1. Here's a 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or so forth. So if I were to graph this, I need a good scale. Maybe I can go in intervals of 5. This would be like a 5, 10, 15, 20, 25, 30, 35, 40, 45, and so forth. Okay, so my time walking is somewhere between 10 and 20 minutes. So here's my 10, and here's my 20. So all my answers have got to be somewhere in that shaded region. What about my time running? My time running needs to be between 30 and 45. So if that's 5, 10, 15, 20, 25, 30 is here. It's got to be above that line here. And it's got to be below 45. So that's 30, that's 35, 40, 45 is here. So that would be in that shaded region right there. See that box? Any point that's in that box makes that true. So what's my second constraint, though? My walking plus my running has got to be less than or equal to 60. Now remember, walking is x. Running is y. That's less than or equal to 60. So if I were to solve that for y so I could graph it in slope-intercept form, y would be less than or equal to a negative x plus what? 60. So this has a y-intercept of 60. So that's 45. That would be 50. 55, 60. It's here. And then my slope's a negative 1. So that's the same thing as going down 1, right 1. Right? Down 1, right 1 would put me there. Right? If I go down 1, right 1, that puts me at 15. Right? If I go down 1, right 1, that puts me at 20. If I'm looking at this where it's crossing somewhere like that. And then I would shade down below it. Now, the only feasible points on this is the intersections of these lines. So that is a feasible region, that's a feasible region, that's a feasible region, that's a feasible region. Okay? All of those correspond to these answer choices. 50, 10, 45, 15, 40, 20, 30, 30. Okay? If you want to verify those points, we can verify those points with graphs, but I'm not going to try to trick you on the test. Okay? Every answer choice are coordinates or vertices of the feasible region. So how do you know which one maximizes this? Well, you just plug it in. So if I just plugged in that C, or if that the W, the time walking and the time running, and find out which one gives me the most calories burnt, I can answer this question. So let's just do that. Let's just cut on your calculator, right? Let's just clear it out. So I'm going to go to Doc B so you see a clean page. And then enter the first one. If I spent 40 minutes running, that would be 10 times what? 40. The time running is 10 calories per each minute. Plus 10 minutes walking, at 4 calories per each of those minutes, so it would be 4 times what? 10. How many calories did I burn there? 440. So right now, A, I can burn 440 calories. So let's check out B. It'd be 4 times the time walking in B is 15, plus the time running is 45, and I burn 10 calories per each of those 45 minutes, and that would be at 510 calories. So I can burn more there, right? And then C, it'd be 4 times the time that you spend walking there is 20 minutes, plus the 10 calories per minute for the time you spend running is 40 there. How many total calories do I burn there? 480. And then D, finally, 30 minutes running, 30 minutes walking. So that would be 30 times 4 plus the 10 times 30. And I get 420 calories. So which one burns the most calories? B. And those are points that are within those restrictions. 45 and 15, that's that point right there. 45 and 15 is where we would cross. Okay? And so you can burn more than 500 calories? Absolutely yes. So that's why it's B. Okay? So use your answer choices to help you on a problem like that if you can't graph it or if you get stuck. Alright, once again, graph the system of constraints, then find the values of x and y that maximize or minimize its subjective functions. What did I just tell you a while ago? I'm not going to try to trick you. Every one of these are coordinates of the vertex. So all I've got to do to solve this problem is just to plug in my x's and my y's into that function rule and find the one that's going to give me the maximum value. So in this problem, all I've got to do is check each one. So let me go to Doc B to clear that out by just taking 2 times x, which is 0, plus 3 times y, which is 0, and that's 0, right? Obviously, that's not going to give me the biggest value. All right? And then I can do the same thing again. If you just want to retype the last thing you did and edit it by going through and hitting delete, you could just highlight it and hit enter. And then edit that x to be 0, and then this y by hitting delete to be 7. And there's 21. Go back up and highlight that one, hit enter, and it recopies it. So the next one is 3, 7. So I've already got the 7, so just enter this x to be 3. And then 27 is bigger, so far C maximizes it. What about D? Highlight it. And then in D, my x is what, 0? And my x is 3. And my y is 0. And so I get 6. Which one maximized it? Let's see. Pretty easy, right? I told you I'm not going to try to fool you on the test. So you can use those answer choices to help you. So what about this one? Graph the system of constraints and find the values of x and y that maximize or minimize this objective function. What am I trying to do with this function? Minimize it. Minimize what function? The cost to be x plus 4y. Which one do you think is going to give you the smallest one? Could you do that one mentally? What's 0? If x is 0 plus 4 times 0. 0. You think any of these are going to give you anything smaller than 0? This one's going to give you 80. This one's going to give you 10 plus 40, which is 50. This one's going to give you 15 plus 0, which is 15. So the smallest value is 0 when you plug it in. 0 is your x plus 4 times 0 is your y is 0. Do y'all need more help, or do you want me to stop and y'all do the rest on your own? You want me to continue working? Alright, well let's do this next one then together. Plumber A charges $25 for a house call and $50 for each hour spent on the job. So can you tell me an equation for plumber A? How's he getting paid? How much money is he going to earn? The money that he earns, which we'll call Y, is equal to what? $25 for a house call and $50 per each hour. So let's just say the number of hours he works is X. So it'd be 50 times X plus $25 just for showing up. What about plumber B? How much does he get paid, which is Y? The amount that he gets to charge. It's $35 for a house call and $45 for each hour spent on the job. So it's $45 per hour plus how much for the house call? $45. Okay, here's the question. If your job's going to take you 4 hours to complete, which plumber should you use? So what do? Figure out the cost if this is for 4 hours. Figure out the cost if this is for 4 hours. Might be an easy way. So what would this one cost for 4 hours? Well, what's 50 times 4? $200 plus 25 would be what? $225. What would this one cost? 45 times 4 is 20. 16 and 2 is 18, so 180 plus 45, which is 5 to 225. Okay? So if your job's going to take you 4 hours to complete, which plumber should you use, and how much is it going to cost you? Did I do my math right? Let me just double check my math. I know the first one's right. Let me check the other one. 45 times 4. Plus 45?
35.
Oh, $35 per hour. Sorry. Plus $35 per hour. It would be $215. Okay, good. So which one would you use? Plumber B. Why? It's going to be cheaper, about $10 cheaper. So which plumber should you use? I would use plumber B. And then which plumber, how much is it going to cost you? It's going to cost you $215. So that's D. Pretty easy question, hopefully. All right, let's go to the next one. Which point gives the minimum value of this? It's 3 times x plus 2y. Just plug in your x's and your y's, and which one's going to give you the smallest one to my answer. So let's try the first one. 3 times 1 plus 2 times 2. And then try 3 times the next one plus 2 times the y value. So that'd be 1 and 5. 3 times x plus 2 times y. Figure out what that is. So what if x is 5 and y is 5? And then 3 times 6 plus 2 times y, which is 4. And just figure out which one's the smallest, right? Because I want to minimize this. Y'all do know this for a grade, right? I hope you're writing it down. So I might give you the exact same test tomorrow. Who knows? 3 plus 4 is 7. 3 plus 10 is 13. This is 15 plus 10, which is 25. And this would be 18 plus 8, which is 26. So which one of those gives you the smallest value? The first one. Alright, I'm going to do one more and leave the rest for y'all to do. Write a system of inequalities that has an infinite amount of solutions. Okay? This is a bad question because all of these typically have an infinite amount of solutions. So if you look at your first one, your x is greater than 0, your y is greater than 0, and then if you were to graph so if I were to graph that would be in quadrant 1, and then this would be y is less than, and negative x would look like this. It would be less than that. That one has no solution because the shaded regions would never overlap. Does that make sense? So the first one's saying it has to be in quadrant 1, so A would be no solution. I'm looking for the one that has an infinite number of solutions. So if we looked at B, what B would look like is this. You have x is greater than or equal to 0, so over here. And then y is less than or equal to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that would be down below that one. So we're looking only at this shaded region here so far. And then my next one would be 3x plus 6. So this would have a y-intercept of 6. And it would have a slope of 3, so I'd go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Look, this right here would be shading the values above that. That would be no solution because there's not an overlapping region for all 3 of them. So then let's check the other one. So this says x is greater than or equal to 0, y is greater than or equal to 0, which means it has to be in quadrant what? 1. And then the second equation says y is less than or equal to a negative x plus 3. So it has a y-intercept of 1, 2, 3, which is good. And then it has a slope of negative 1. So you'd go down 1, left 1. Oh, sorry, down 1, right 1. down 1, right 1, down 1, right 1. So it looks something like this. And then we'd be shading in what values? The values that are greater than that or less than that? Less than the negative x plus 3. So this is the shaded region we're looking at. And then my last one would be y is greater than a 2x plus 3. So there's my 1, 2, 3. And then I have another positive 3 here. And then if I were to graph that, that would have a slope of 2x. So I'd rise up 2, run to the right 1. And then it would be a line looking like this. And I would shade in all the values that are what? Above that line. So all these values and all these points, there's only one solution that would be in that triple shaded region, and that one's right there. That's not an infinite amount of solution. This would have one solution. So by a process of elimination, it must be D. And the reason why it's D is this. If you were to shade the x values that are greater than 0 and the y values that are greater than 0, that's in quadrant 1. Everybody agree? And then if I were to graph the second equation, it has a y-intercept of 1, 2, 3, 4, 5, 6, 7, and has a slope of negative 1. So I go down 1, right 1, down 1, right 1. Looks something like this. And then I'm going to shade in all the values that are what? Less than that, which would be in this region right there. That's still an infinite amount of solutions in that region because I can have decimals and fractions and decimals and of decimals, fractions of fractions. So I could find points all day long in that triple shaded region. And then my last equation is x plus 2y is greater than or equal to a 7. If I move that across, I get 2y is greater than or equal to a negative x plus 7 divided by 2 divided by 2. I get y is greater than or equal to a negative 1/2 x plus 3.5. So that has a y-intercept of 1, 2, 3.5 and a slope of down 1, right 2. Right, down 1, right 2, and so forth. So it looks something like this. And then shade in all the values above that. So there's my feasible region. And how many points are in that feasible region? Infinitely many. I can find points all day long by using decimals and decimals of decimals and so forth. Okay, that's all I'm going to get for y'all. The other 4 y'all can do on your own. You should be reviewed and ready for your test, hopefully. I'll post that for y'all too.